For a long time now, I've been kind of obsessed with a question, and to try and answer it, I actually built something I want to show you. It's called PicInspector, and it's basically an AI that I taught how to analyze photographs.
And that question is this: what really makes a good photo? I mean, you've been there, right? You're scrolling through your camera roll and one picture just pops. You know it's a great shot. But if someone asked you to explain exactly why it's great, well, that's where things get tricky.
It's always this mix of things, isn't it? It's partly a feeling, it's subjective, but it's also technical. It's the composition, the sharpness, the colors, and trying to put all that into words is tough. That is exactly why I decided to build PicInspector. I wanted to create a tool that could untangle all of that and give you a straight answer.
So let's officially introduce PicInspector. At its heart, it's an AI-powered tool designed to really dig into image quality.
So what does it actually do? Well, it works in three key ways. First, it gives you quantitative scoring, the hard numbers on things like sharpness and color. Second, it has scene understanding, so it knows if it's looking at a landscape or a portrait. And third, and this is the cool part, it gives you natural language feedback, a real human-sounding description of your photo's quality. All right, let's dive into the first half of PicInspector's brain, which I call the AI Critic. This is the part I taught to speak the actual language of photography. The engine behind this is something called a vision language model. You can just think of it as an AI that can build a bridge between what it sees in a picture and the words it can use to describe that picture. I specifically used a model called Small VLM because it's both really smart and efficient. Now, I didn't have to build this thing completely from scratch. I took that existing Small VLM model and then fine-tuned it for my specific purpose. I used a really efficient method called LoRa, which lets you teach a big model a new trick without having to retrain the whole thing from the ground up. It saved a ton of time and resources. But here's the thing about any AI. It's only as smart as its teacher. And in this case, the teacher was data, a lot of data. I used over 17,000 images, each one with a detailed human written critique, to teach the AI Critic what makes a photo good or bad. And after all that training, look at what it can do. This is a critique generated by the AI. It's pretty amazing, right? It points out the good stuff, like high clarity, but it's also honest about the flaws, like the lack of distinction in the colors. It sounds almost human. Of course, I couldn't just feel like it was working, I had to prove it. So I measured its performance using a metric called Rouge. It basically compares the AI's generated text to the original human descriptions to see how similar they are. And these scores showed me, yep, it was definitely on the right track. It was learning to speak the language. Okay, so that's the critic, the artist. Now let's meet the other half of the system, the AI Analyst. This is the scientist, the one that's all about crunching the numbers. For this part, I needed a different kind of AI, what's called a multitask model. It's a total workhorse that can do several jobs at the same time. I built this one on top of a powerful model called Dino V2 and gave it two jobs: score the photo's technical quality and figure out what kind of scene it is. So to get a little technical for a second, what I did was take the base Dino V2 model and add two custom heads to it. One head is for regression, that's just a fancy word for predicting numbers, like a sharpness score. The other head is for classification. That's for assigning categories, like cityscape or night scene. Training this model was a bit of a marathon. I used another big data set of photos, and it took 10 full passes through all of that data. We call those epics, to get the analyst to perform the way I wanted it to. And here's what it spits out. For any photo, the analyst gives you this clean breakdown. You get an overall score, called the MOS, and then individual scores for everything from brightness and contrast all the way to sharpness. Pure data. And remember, it's a multitasker. So at the exact same time it's generating those scores, it's also analyzing the scene. For this image, it recognized that it's a mix of a cityscape, a night scene, and a still life. Pretty clever. So we've met the artist and the scientist. Now for the really fun part. Let's see what happens when we put them together to look at the same photo. The workflow I designed is about as simple as it gets. You just load up an image, PicInspector automatically sends it to the critic to get that text description, and to the analyst to get the hard numbers. You get both sides of the story instantly. Okay, let's test it with a blurry photo. First up, the AI Critic's verdict. It immediately gets to the heart of the problem. Serious focusing issues. Blurry. It doesn't pull any punches either, seeing the quality is poor. And then boom, the AI Analyst drops the data. Look at that sharpness score, 15.57. That is incredibly low. And this is the magic right here. The critic's words are perfectly backed up by the analyst's numbers.
The two brains are working in perfect harmony.
So, okay, this started as a personal project, a way to answer a question that was bugging me. But what's the real-world potential here? Why does something like this matter?
Well, this is where it gets really exciting. Imagine you're a photographer and you could get this kind of feedback instantly in the field. Or think about social media sites being able to automatically flag low-quality uploads. It could even power editing software that suggests exactly what you need to fix, or help online stores make sure their product photos are top-notch.
So, to sum it all up, the main idea behind this whole project was to bridge a gap. I managed to combine two very different types of AI, one that's descriptive and artistic, and one that's numerical and technical, into a single tool that gets the whole picture.
And that brings me to one last big question that I want to leave you with. My project is just a small step, but as AI gets better and better at not just seeing, but understanding and critiquing art like we do, how is that going to change what we, as humans, create? What happens next?